Oh, hi, I'm Michael Fudge. I'm just here playing this arcade game. I'm hoping that you'll get the high score on this lesson and you won't need 3 lives to do it. Okay, we're in Unit 3, where we introduce the SQL language. We will take what we learned in the previous unit about the relational model and the relational theory, and we will apply it again, but this time we'll use SQL. So what's on the agenda? What is SQL? Brief history of SQL. We'll talk about some naming conventions, and then we'll go through the various aspects of SQL, including data definition, data manipulation, how to inspect schema, and also I'll show you how to build scripts so that you can rerun your SQL script and it will drop and recreate your objects every time. So let's get into it. What is SQL? SQL is a programming language, but it is domain specific. A domain specific language implies that it serves a specific purpose and is not designed for general purpose programming. So, for example, languages like Python or C# or Java or even JavaScript, you can pretty much write anything you want in those languages. SQL is really just designed to do data manipulations, data management, metadata, creating metadata structures, and data logic. So SQL is domain specific to databases. It really lets us build this metadata, creating tables and structures like that. And it also helps us get the data in and out of the database through data manipulation. So there's 2 branches, well, there's several, but there's 2 branches mainly that we're going to look at of SQL today, and one of them is the data definition language, which is, for SQL, and then there's the data manipulation language, which lets you get the data in and out. So let's put a perspective on this with the database development life cycle, right? So we have planning, we have analysis, we have design, we have implementation, and then we have maintenance. And when you're learning about SQL, you're really living in the implementation phase of the database development lifecycle. This is where you actually create your artifacts, you put data into tables. You can also talk a little bit about maintenance, but in maintenance, you're using the SQL that somebody else wrote to get the data in and out of the database as part of a database application. So what's really interesting about SQL is it has this very declarative nature. That is, when we're talking to the DBMS itself, we don't have to explain how it's done. We just have to explain what we want done. So for instance, you might just say, insert these values into the orders table. And then the DBMS would say, okay, I inserted a row for you. And then you might tell the DBMS, select all the emails from the customers table where they live in the state of New York. And then the DBMS would say, here's 14 rows for you. The point here is that the commands we write, these commands in blue, we don't have to explain how to do it. We just explain what we want. Normally, if you're going to try to do the select statement, and you're going to write it in a programming language like Python or Java, you would have to use some kind of loop to do this. You'd have to iterate over the rows in the table and figure out for yourself which customers live in which state. The nice advantage of using SQL is you don't have to do that. You can if you want, but you're going to see that the majority of times you do not have to do that. So let's talk about the history of SQL. SQL is a language that was developed by Chamberlain Boyce at IBM in the 70s. It was based on Ted Codd's relational design paper, which was really the foundation of the relational database model as we know it. In 86, there were several, it was standardized, and then there have been several revisions since, and each revision adds new features to the standard. And one thing that you really need to know is not all DBMS vendors follow this standard, unfortunately. So you will learn SQL, and the mileage that you get from the language will really vary depending on the actual DBMS that you're using. And this is just sort of a reality of the SQL language that we all have to live with. So how do we interact with the DBMS? Well, there's a DBMS client that sits in the middle, and this is a piece of software that communicates with the DBMS over a network, and you generally will interface with the client. And clients are helpful because they support us in our SQL writing. For example, if we don't know the name of a table, it will try to suggest one. Or if we can't figure out the name of a column, it will suggest one. There are good clients and bad clients. Some clients don't give you any help at all. But we type our code into the client sends the code to the DBMS when we tell it to execute the code in the client, and then the DBMS returns a result after processes back to the client that we can look at. And this is basically how we spend our lives interacting with the DBMS. No one really talks directly to the DBMS on the server. You're always interfacing through some client, and that client works over a network. This is how all modern DBMSs work. We will use Microsoft SQL Server 2017 as our DBMS. And then there are 3 clients that we will use. There's Azure Data Studio, there's SQL Pad, and then there's AdMiner. And SQL Pad and AdMiner are web-based, and Azure Data Studio is a true client that you would install on your laptop or computer. All right, let's talk naming conventions. Naming conventions are important so that you're going to be naming a lot of objects in the relational database implementation. And it's important to be consistent in the naming of these objects. For example, if you want to name a table, you don't want to have one table that's in uppercase and another table that's in lowercase, because technically these are 2 different tables. So I will always use lowercase values for my all object names. Table names will just be what they are. Object names will use underscores if I ever need to use a space, rather than delimiting with brackets like this and putting a space in there. Just make my life easier and use underscores. All my tables will be plural because they contain more than one thing. So it's a table of employees because it has many employees in the table. Every column will be pre-qualified with the table name, so it'll be employee zip code or vendor zip code rather than just zip code. And my constraints will have a prefix, so PK for primary key, FK for foreign key, U for unique, CK for check, I for index. And I will always include a dependent object, so it's going to be U customer email and U vendor email. It wouldn't just be U email, because I want to make sure that globally all of my names are unique. So this is just something you'll see me doing. It's not anything that you need to sort of memorize or become proficient in yourself right away. I think what you'll see is, as I go about doing what I do, you'll learn from me. So let's go through the 2 pieces of SQL that we're going to really focus on. The data definition language. This is for manipulating objects or metadata in the database, like making tables. And there's 3 basic commands. There's create, alter, drop. Create creates the object, alter lets you manipulate certain facets of the object, and drop will remove the object outright. On the other side of the coin, there's the data manipulation language. These are the CRUD operations. And we have commands called insert, which does creating data, select for reading data, update for obviously updating data, and delete delete for deleting data. That says select, but that should say delete. So let's go through creating a table now. And when we create a table, we have this syntax. And whenever you see one of these diagrams, what's in blue are keywords. So these are part of the SQL language. So constraint and primary key, these are part of the SQL language. And then these things in italic are things that you have to put in. So it's create table and then the name of your table that you're making. Maybe it's called orders. And then you put a parenthesis in here. And then you have a list of columns that you want. And then to establish entity integrity, we want to set a primary key constraint. This is a best practice. We don't have to set a primary key constraint, but we should get in the habit of doing so. So items in uppercase, they're going to be keywords. They'll also probably be in blue. Items in italic should be replaced by the actual object names. And when you see little things like these pipes, this means either or. It means you're either going to put in null or not null. You can't have both. So you're going to learn more syntax diagrams as the syntax gets more complicated, but I thought I'd try to keep it simple to start. Before we can actually create a table, we need to understand the SQL data types. There are basically 4 different kinds of data types. There are exact numerics, which, as the name implies, are not estimates of numbers. They are actual numbers, and these are ints and decimals and bits, which are true-false values. Then there are the approximate numeric types, like floating point numbers, like real and doubles, right? These allow you to represent really large or really small numbers, but they're all approximations. They're not exact numbers. If you're going to do anything scientific, you're probably going to want to use reals and doubles. If you're going to do, some kind of financial math, you're going to want to stick to the decimals. Then we have our text types or string types like char, varchars. Varchars are, character length where the size is not to be determined. Char is an exact type. Like if you know it's still always going to be 2 characters, there's a benefit to using just char. And then nvarchars allow us to use Unicode rather than picking a certain collation. So when you use varchar and char, you have to sort of, pick which code page you're on. Usually we're using Latin 1 as the code page in this class. But there's other code pages out there, like you can pick the Cyrillic character set or for example. So if you pick Unicode, you actually have support for all the characters and all the character sets. So nvarchars take up more space than varchars because they need extra bytes to store the Unicode characters. Then there's your date time type. So dates, times, and of course date time together. All right, it's time for our first code demo. In this code demo, we are going to create the table that you see on the screen here, books, and we will make it in the demo database. And the logical model is over here to the right, and then we will verify the table was created with the tool, and we'll use SQL Pad for this particular demo. So I encourage you, as I do these demos, to code along with me if you want. I do not type fast enough where you will not be able to type as I type. And if you encounter problems, pause the video so that you can sort of look at your screen, look at my screen, and figure out what it is you're doing wrong. This is what's going to make you a better SQL programmer, is to practice as I practice. Okay, let's get into it. All right, here I am out in the SQL Pad web application that is on my local machine because I set it up that way, and I am already in the demo database, and you can see I do not have a table called books, so I'm going to create that table now based on the specification I had on the PowerPoint slide. So I'm going to say create table books, and then inside the parentheses I'm going to put my column names. I'm going to have a book ID int identity not null. Int is the data type. Identity is a special keyword that says I would like this to be a surrogate key. And if you do not specify how you want the circuit key to behave, the default is start at 1 and increment by 1. But I can certainly say start at 1 and increment by 10 if I want as part of identity, or start at 10 and increment by 10, 10, 20, 30. But usually I just go with int identity. I don't really care how the identities are made. I just need the DBMS to make the surrogate key for me. All right, then I'm going to have book title, and that's going to be a varchar, and let's make it a varchar 50 in case there's very long titles, and that's going to be not null. I want to make sure there's values there. And then book author first name, let's make that a varchar 20, not null. I want to make sure that that's required. I'm going to zoom this in one more level. Last name. Okay, 20. Not null. A lot of typing. But you know what? It's good to not copy and paste these lines, but to just type. Practice the cadence of typing. You're going to get better if you do that. So we'll have book retail price, and this is going to be a decimal. And now when I use a decimal, I'm going to do, let's do 5.2. Now what decimal 5.2 means, and I'm going to allow nulls here. So maybe it doesn't have a price. So rather than make the price 0, I just want the price to be null. A price of 0 means the book costs you nothing. A price of null means you haven't set a price on it. So I want to have that option, so I'm going to leave it null. Now let's talk about decimal 5.2. What does 5.2 mean? 5.2 means 5 total digits. 2 means 2 to the right. So I cannot have a $1,000 book here. My highest book would be $999.99. Okay, I'm fine with that. That's good enough for this particular application. Why not just make this a really big decimal? Well, you're wasting space. So again, you don't want to use up too many bytes per row. If you do that, then your tables are going to get excessively large rather quickly. It would be a real bummer to make a table row where 50% of the allocated space is never used. Because then what's going to happen is whatever the size of your table is, it's going to be 50% larger than it needs to be. And you might say, well, that's not a big deal, but if your table size gets up to a gigabyte, now your table size is 2 gigabytes because you've just wasted 50% of the space. Now, the other side of that, if I may go off on a little tangent / rant, is the larger your tables are, the more time it takes the computer's CPU to find the things that are in there because it's got to jump around a little more. So you're better off trying to keep your tables as small as possible. Now, let's not be like let's not stress out over this, but just be reasonable with your data type sizes. So let's do pages. Book, number, pages. Now, this could be an int. Now, technically, an int is a 4-byte integer, which represents numbers up to the billions. Pages don't have billions. Books don't have billions of pages in them. So I can use a small int, which is a 2-byte integer, and then I don't have to worry about using up all that extra space if I want. Okay, I'm just going to use int for now just to keep things simple. But it's probably not a very good choice. And I'm going to make this not null. And then let's do the book edition. And then let's make that a varchar 10. And let's make that null. And we're going to set a primary key. So we're going to say constraint. I got to type it right. Constraint PK books book ID. That's how you build a global identifier, right? It's a primary key constraint on the books table using the book ID column, and it's going to be a primary key constraint over the book ID table. That's my code. I run my code. So this is the client. When I hit run, it sends the code to the server. And then I get back that it worked. And then if I come over here and refresh, now there's the books table, and you can see the columns in the books table. Okay, let's talk about the SQL insert statement. So here's the syntax for the insert statement. Insert into whatever you want to call your table name, and then these are the columns you're going to insert data into, and then under the value section, you put the actual values. So the values correspond to the column. So if this column says book title, this should be the book title. If this says number of pages, this should be the number of pages. They don't have to be in the same order that they were that you created the table, but the order that you put them in the insert statement, the values have to match that order. So again, values have to correspond to the columns in summary, and any columns omitted from this insert part will be considered null, or their default value will be used if a default value was set. You can insert additional items by just including more values. So if I have this list of values and then I hit comma, I can include another list of values. And then in one insert, I can insert, 4 values if I want. Okay, it's time for another demo. We're going to go back to SQL Pad, and we're going to insert these 4 books here that you see to the right. And then we'll verify they were inserted using the tool. Okay, let's give it a shot. All right, here I am back in SQL Pad. I'm going to make a new query. And in that query, I'm going to do my inserts. Now, because book ID is a surrogate key, I do not need to include it in the list of columns. Book title, book author, first name, book author, last name. And this is already going to span too far, so I'm going to move this down. And then we need book retail price and book number pages. And then we're going to say values. And then in parentheses, we're going to put the corresponding values. So the art of war, Sun Tzu. That book price is $9.95 US, and then we're going to have 260 pages. And then let's do it again. Frankenstein, Mary Shelley. Told you would have time to catch up with me as far as the typing goes. I am by no means a fast typist. A Christmas Carol, Charles Dickens. This is, we don't have a price for this. I'm just going to insert null. And it's 110 pages. And then let's put in the time machine. And let's do H.G. Wells. And let's put in 995 and 84. Now I have an error in here on purpose so that we can see what happens. It says incorrect syntax near 84. So that's all you get. for an error when you use SQL Pad. Not very helpful. This is why, for really complicated queries, I like to use a better client. So I'm going to put this in Azure Data Studio, and then I'm going to run it. And, you know, it says line 7. At least it gives you a line number, right? So it says there's a problem near 84. So usually when the problem is near here, it's usually before that, because think of the way the parser works. Okay, it reads this, then it sees the comma, okay, and then it reads this, and then it reads this, and it says, whoa, where'd my comma go? So there, now I fixed it. So let's run it. 4 rows affected. And now let's see if we can go find our rows. Books. And there's our rows. And there you have it. See, for book edition, it just put all nulls in there because we never specified that as a column in the insert statement. We didn't put book edition in there. We ended at number of pages. And it put in null for retail price. Cool. All right, let's talk about using alter table. So there are many flavors of the alter table statement. So you can use alter table and do something with columns. You can alter table and add a column. So alter table, let's add a column, and then you put the column name you want to add. You can only add 1 column at a time with alter table. You have to repeat alter table. You want to add 2 columns. It's just, that's all right. It's the nature of the beast, but it's not bad. You can alter table and then alter a column, that is, find an existing column and change it. You know, like maybe you expand the data type from varchar 20 to varchar 40, or change it from null to not null, or not null to null. You can alter table and drop a column. What you can't do is rename a column. To rename a column, you actually have to create a new column, move the data into the new column, then drop the old column. That's all on you. So before we get into more alter table, let's talk again about the data integrity constraints. These are from the last unit. So we have the primary key constraint, which establishes any integrity. We know about that one. There's a unique constraint, which allows us to put, take a natural key and make sure that it functions as a true natural key. It also lets us to establish entity integrity when we have a surrogate key. We can have a check constraint, which is a condition that must be true prior to data being written, and a default value constraint, which is used when no value is specified. It's the value that will be used instead. And then, of course, the foreign key constraint, which establishes referential integrity. So let's take a look at how you add these constraints with alter table. So here's alter table, add a primary key constraint. Here's alter table adding a unique constraint, and you put the column or columns here. If there was 2, you just separate them by a comma. Here's how you alter table and add a check constraint. You know, it's all the same. Alter table, add constraint, name of constraint, and then primary key, unique, or check. And then here's how you add a default. And with default, there's a little twist. You have to say 4. So it's default. You know, the default might be 0, 4, and then this might be book number of pages. And then we have the foreign key constraint, which is the most wordy of all of them. And in here, you add the constraint named foreign key. That's the column in the table you're altering. And then you have to specify the referring table, which is always some other table's primary key. And basically, that's how you add the different constraints, and then dropping them is pretty simple. You just drop them by name, which is why you want to make sure that you name your constraints well so that you remember what they were. And of course, this is how you drop a table. Drop table, name of table. And deletes the table and all the data within it. Okay? So let's play around with some of this in another demo. And in this demo, we're going to stick with Azure Data Studio. And we're going to make a table for a lookup table. And then we're going to alter that table and add some logical domain to the books table. We're going to add some check constraints and some default constraints. And then we'll add a foreign key constraint. And then we'll play around with our constraints and make sure they work by doing some inserts and things like that. Along the way, I'm going to try to create this into a single script, but I might save that till the end of the unit. I might show you how to do that at the end of the unit. Okay, so let's get on with the next demo. All right, here I am out at Azure Data Studio, and the first thing I need to do is make my lookup table. So create table additions. I'm going to call it book additions lookup. And in here, I'm going to say addition. And I have to make sure this is the same type as the books edition here, which was varchar 10. See that? It's kind of hard for you to see. Varchar 10. They need to be the same type. Varchar 10. Not null. And then constraint pk book additions lookup addition primary key addition. All right, so that's step one. And now I have in my demo database a book additions lookup. Now, if I run this again, it'll say you can't do that because there's already an object named book additions lookup. So one of the things I might want to do if I want to run this more than once is I can put up here, I can go drop table. And usually when I use drop table, I like to use if exists. That way it will run correctly the very first time you run it. And then because you can't drop a table and create a table in the same batch, I use what's called the batch operator go. And what this does is it separates this one database script into two batches. In essence, it runs this first, then it lets the DBMS digest that, then it runs this next. Okay, that's what Go does. It splits this into one batch, as opposed to if I remove Go, it sends all of this to the server at once, and then it runs all of it at the same time, which might not give you the results you want. So that's what Go does. Go is specific to Microsoft SQL Server, but every DBMS out there has a means to batch statements like this. So now I can run this, and every time it removes the table and then recreates the table, which is fine while I'm building it out, but I probably wouldn't want to do this in practice for an extended period of time. Now, from before, I had the books table, right? So let's take this books table and let's put that in here. Let's put another Go. We'll batch this. Right? And so now I can drop them both. I can say drop table that, drop table if exists books, right? And now this one script does both tables, right? Okay. So we're not going to do that right now, but I think maybe at the end of the lesson I will batch the whole thing and show you how that works. It's a good technique to learn how to do. So let's go on and add some additions. Insert into book. See how it's helping me out now? That's why I like Azure Data Studio. The first edition, the second edition, and let's just make a third edition. That'll be good enough for now. Again, the purpose of the lookup table is you cannot add values to the books table unless they're one of these. You can't add an addition to a row in the books table unless it's one of these three values. Okay, so there we go. Let's just check it. There they are. Okay. Now let's add our constraints to our books table. Let's alter the books table. And let's add a constraint. Let's add a column. Let's add a column called book ISBN. And I cannot make that column not null, because if I do, let me show you what happens here. If I try to run this, just going to highlight this because I just want to run this, right? So that's another nice trick, is you can just highlight what you want and run that. I did that wrong. Got to spell column right. Oh, I don't need column. All right, I was a knucklehead there. I don't need to put the word add column here. I only need to include the add column when I'm doing an alter. Then I need to say the word column. So no column keyword here when you do add. It's just alter table add, and then what are you adding, right? So I go to add this book ISBN, and I get this error that says definition for column book ISBN must include a data type, right? So I need to say varchar 10, and then I run that, just highlighting it to run it, and then it says it only allows columns to be that contain nulls, because what is the value of it, right? There's already rows in the books table, so what is going to be the value of the ISBN? So, and I have no default, so I'm just going to say null here. I'll run that. And then it allows me to add that. Now we can add a unique constraint on it. Now, granted, there's nothing in it, but that's all right. We will learn how to update the table later and add the ISBNs to it. Just baby steps here. Alter table, books, add constraint, u books, book, ISBN. So this is the natural key. ISBN, so we're going to add a unique constraint, and it's going to be on book ISBN. Okay. Let's give that a run. Oh boy, I forgot the word unique. See, you fall asleep for 1 minute on this job and you create all sorts of errors. Okay, so that should add the unique constraint on there. Let's try it. Okay, so it has a problem because there's values of null in there. So I'll add this unique constraint later after I insert the data in there. Okay, I'll just hold off on that for now. And let's put some other constraints in there. Let's do this. Alter table, books, add constraint. DF books book edition, right? I think that's what it was called. Book edition. And then that's going to be a default constraint, and the default value is going to be first edition. And that's going to be for the column book edition. And that's kind of wordy. I'm going to move this around like that. Add constraint like that. And it's complaining about something, as it usually does. Expecting a parenthesis or select. Let's see what we got here. It looks pretty good. it would really help to spell constraint correctly. That takes care of the problem. All right, let's see what we get now. Okay, for book edition. There we go. Okay, so that would add the default constraint. Now, adding a default constraint does not proactively change the values of the column. They still say null. Okay, it's just not the way it works. All right, so let's add another constraint. Let's add a check constraint, alter table books. This is all part of enforcing logical domain. Pardon me. Constraint, check, books, book, retail, price, non-negative. Check constraint, we want book, retail, book, retail price bigger than or equal to 0. Okay, let's add that check constraint. Okay, and then let's do a number of pages, alter table books, add constraint, check books, book, number, book, valid number of pages. Why am I naming these constraints so long? When the error occurs, when the constraint is fired because there's an error, it doesn't satisfy the constraint, you see the name of the constraint, which is a great indicator of what the error is. You know, not a valid number of pages, right? Book pages need to be more than 0, right? You need to at least have 1 page in your book. And let's alter the table books and add a constraint. FK. Now at this point, by the way, I'm probably gonna wish that I had this code here. I just got thinking about this. I'm gonna want to have this code here from the previous example, and I'm gonna want to put my drop up here, or else this entire thing is not gonna work, because I can't be altering the table and adding all these constraints. I can't be altering these tables and adding all these constraints more than once. Like, if I run this again, it says there's already a constraint called that, right? So I'm not going to be able to rerun this entire script unless I drop both tables and then recreate both tables. That's fine. Okay. Alter table books, add constraint, foreign key, books, book, edition, foreign key on book edition, references. The referring table is going to be editions, right? There we go. So that will add my foreign key constraint. So if I go down here to keys, there's my foreign key, there's my primary key. If I go down here to constraints, I see my default constraint and my check constraint. So let me run the entire thing, and the entire thing now will drop both tables. And you notice how I have books first and book editions second, and that's because this has a foreign key. So I can't drop the referring table first. the referring table has to still exist. So I drop the table with the foreign key first, then I drop the referring table second. Okay. Then I create both table, book editions, and books. Then I add some book editions. Then I add a bunch of alter table statements. And then at the bottom of here, I'm going to put in my insert. I'm going to finally insert these books. And I'm actually going to manipulate this insert later to have the ISBN and stuff, but we're not going to worry about that right now. Let's just see if this all goes, and I have what I need. So again, this is the, physical domain, and then all these alters represent the logical domain. Now, could I add all these constraints right in the create table? Yes, you can. You can just keep adding constraint after constraint right here. Comma, constraint. You can just add the next one. But let's see if it runs. And there we go. It runs. And see, every time, every batch that runs, invalid column name book pages. It's book number pages. See that? So I got a little goof in here. Book number pages. See, this is another nice thing about batching, right? This worked, but this didn't, right? And then the next one worked, and then the next one worked. So only the ones in the batch that fail, not the whole thing. So that's another advantage of batching. Okay, and it looks like my whole batch worked now. And if I go back and look at, let's go look at the books table and just select the rows, and now you'll see that they all have a first edition as a default. And the ISBN is still null, which we will fix later. Okay. Cool. So let's test some of these constraints. Let's finish by testing some of these constraints. So let's take this. Let's just open up a new window, and let's insert into books, and then let's put in the book ISBN, and then the book title, and I'm going to look at the columns here, and title, and I'm going to break this out a little more. Books, book ISBN, book title, book author, first name, book author, last name, book retail price, book number pages. That's good enough for now. And then let's put in some values that are going to blow up some constraint, blow up some constraints. So let's do this. Let's put in a book ISBN of 1, and then a book title of testing, and then a book author first name of Mike, and then a book author last name of Fudge, and then a book retail price of minus $50, and then a book number of pages of 100. And this should violate a check constraint. Let's run it. Insert statement failed due with check constraint, check books retail price non-negative, right? So it's telling me that your retail price cannot be negative, right? So that's why you name the constraint the way you do. Okay, so let's put in a $50 book here, and then let's put in number of pages 0. Conflicted with check constraint, valid number of pages. So see, that's the nice thing about check constraints, is they help enforce data integrity, and they make it so that we can't add values that don't make any sense for the logical domain of the columns. Okay, we'll do this more when we learn more SQL statements. So let's get back to the lesson. All right, moving right along, let's deal with data manipulation in SQL. So this is the select statement. This reads data from the table. The brackets, by the way, which are new, mean that this part of the statement is optional. So if you include where, you must include a Boolean expression. Then order by is also optional, and you can include that if you want, but if you do, you must include a column or a set of columns that you want to order by. The where clause allows you to filter based on a true-false expression, and the order by clause allows you to sort the output of the table, of the rows in the table by a certain column or set of columns. So the SQL update statement allows you to update data in the table, obviously, and then you have to set a series of columns and their values. So you don't have to set all the columns. You can just pick which ones you want to set. If you do not include a where clause, it will set all the columns in the table to that. All the rows in that column to that value. So it's important to put a where clause in here to filter or restrict the rows to only the pertinent rows in the table that you want to alter. Okay. So delete's pretty simple. Delete allows us to remove data from the table. If you just do a delete, it deletes all the rows in the table. If you include a where, it will delete only the rows matching the values. So let's take a minute and understand the atomicity of a relational database. So any SQL statement which changes data must succeed or fail as a whole, meaning there are no partial updates. For example, if there are 10,000 rows and you update all the rows with a single statement, but one of the values affected will cause the check constraint to fail, for example, then none of the updates will succeed. This is actually quite valuable. You do not want to have what are called intermediate states where part of the data gets updated and part of it does not, because then it becomes impossible to undo any issues that you have. So what happens is if one of the constraints gets fired, it rolls back all of the operations that were affected by the statement. That's a very useful and helpful thing. It's something that we have to sort of get used to as people new to how this works. It's something we definitely have to get used to because it's something the DBMS does for us, but we maybe aren't really comfortable with understanding that as of yet. Okay, let's move on to yet another demo. In this demo, we're going to use the DML statements to manipulate data in our tables. Okay, let's go and do these things. We'll do some selects and some updates. Okay, let's play around with this using the demo database. Let's just do a select all columns from demo. This is, the blanket select statement. Oh, I'm sorry, not demo, books. All right, and then we get the entire set of data. Let's be a little more specific. Let's select the book title and the book ISBN from books where the number of pages, the book number of pages is bigger than or equal to 150. Oh, it's book number pages, no of. There we go. Okay, so there we go. We have our book titles, Art of War and Frankenstein. There's no ISBNs, and number of pages is more than 150. Now, it would help to see the number of pages and know that this where clause is working. So I'm going to add that back to my select line so I can see that. There we go. So there are more than 150 pages in these two books. Let's also include their ID. Okay. Now, maybe what I'd like to do is add the ISBN to this Art of War book. If I do this, update books, set book ISBN to 1, 2, 3, 4, 5, and I just do that, it's going to try to set all of the rows to the same ISBN. For example, if I go back and run this one again, you'll see that now every single book has the same ISBN, right? And remember, I didn't turn that unique constraint on. So, that ends up being a problem. Let me go back to the code that I had here. Remember, this code drops the table, right? So I'm going to add that unique constraint back now, and I'm going to run the whole thing. Right now, it says violation of unique constraint, cannot insert duplicate key because value is null, right? So now I got to fix that here because you're inserting these values and they're violating the unique key constraint because they need to have an ISBN, right? So I'm going to add book ISBN to this. And now I'm going to add the ISBNs of each of the books. And I'm just going to make something up that's unique. And this one's going to be, and then this one's going to be this. And then the last one. Okay. And let's run that. There you go. And now they're in there and the ISBNs are in there. So I can run this and I will see different ISBNs. And then when I try and do this, I'm still going to violate a unique key constraint because I cannot make all of the books have the same ISBN because it violates one of the constraints, which is what we want out of a natural key. So let's change this ISBN of Art of War. So let's make the new ISBN 99999, and let's say where. And generally when you use update and you want to pinpoint one entity in the output, you use the primary key. And like down here, I'm going to do select book ID, book title, book ISBN from books. So you can see what happened. So I'm going to run this update. One row affected, which is what we want. And then I'm going to run this. And now it has changed that book ISBN. Now, interestingly enough, the update statement does not discriminate. If you run this command again, it actually doesn't update. Okay, it updates every time I run it. Even though it's not changing the value technically, it's still running an update. Okay, it doesn't know that the value is the same and not to update it. It doesn't work that way. It just does the update. Whatever was there gets replaced by this. Now, if you want to update a couple of things, you can. Like, see, it says A Christmas Carol. That's not the right name. So let's fix that. So update books. Let's set the book number pages to 151. And then let's also set the book title to A Christmas Carol instead of A Christmas Carol. And then we need to say where book ID is a 3 in this case. Okay. So we'll run, and now I'm going to add to this book number of pages so we can see what's going on here. So that's it's 110 pages before, and it says a Chris Mann Carol. So then I'm going to run my update, and then I'm going to run my select again so I can see that now it is 151 pages and it's a Christmas Carol. Okay, so that's how the update statement works. Now, you can update all of these at once. For example, I can do update books, set book edition to second, and this will set all of them to the second edition. So let me add book edition. I'll put this down here. So right now, they're all first editions. I run this, and now they're all second editions. All right. Once you update something, there is no undoing the update. It's permanent. So if you make a mistake, the only thing to do is to do the reverse, right? This is like what I call the Walmart principle. I go to Walmart, I buy something. The minute I buy it, I got to go in the returns line. I can't undo a buy, right? I have to do a return. So same thing happens here. I want to undo that. I have to just run the reverse operation. There's no getting around it. Okay? This is different than violating a constraint and causing a rollback, as I said before, where there is the atomic nature. And let me demonstrate that. If I were to subtract let's set the book number of pages to the current book number of pages minus 200. And let's do that for all of the books. So if I take 200 pages away from here, the book is now 60 pages. This one's 80 pages. This one is now negative 49, and this one is a negative number as well. These two violate a check constraint. These two do not. But because this is one statement and we cannot have intermediate states, what happens is the whole thing does not work. And therefore, none of the rows get updated. They stay where they are. This is what we mean when we talk about the atomic nature of a relational database management system. It ensures us that we can't have a partial state, right, where these two rows work and these two rows don't, because the statement affects all the rows in the table. So they all must satisfy the conditions of the update. Okay, that works to our benefit. If you wanted to update these individually, you'd have to put a where clause for each of the rows, where 1, where 2, where 3, where 4, and apply it that way. In that case, the ones that succeeded would succeed and the ones that failed would fail. Okay. So let's continue this with a delete. So let's do an insert. And let's just insert something bogus here. Book, ISBN, book, title, book, author, first name, book. Well, I don't need to do an insert. You've seen inserts before. Let me just delete things because I can always get them back again because I have that in my query over here. So, why mess around with it? Let's just have fun nuking stuff out of the database. Let's delete the time machine. So delete from books where book ID is 4. Run that. And then let's just take a look at what we've got. And it's gone. Let's do this. delete from books where book number pages is more than 200. This is going to delete these two rows. Boom, gone. All right, and then last but not least, let's just delete everything from the table. And to show you how this works, I'm going to go back here and rerun this. Right, and now I've got everything back in the table again. If I go back here and show you this select, all the data is back in there. And let's just delete everything. Delete from books. That removes all the rows from the table. Gone. Now, it should be noted that the next row that gets inserted is going to increase the surrogate key. The surrogate key, last surrogate key was 4. If I insert a row now, it's going to be 5. Okay, and that's just the way that surrogate keys work. You don't really care what the number is. You just want it to be unique. Okay, back to the lesson. Okay, the last thing to talk about on the agenda is information schema. Information schema is a SQL standard that allows us to query the metadata, that is the database management system objects, using the select statement. It's been part of the SQL standard since SQL 92. And what it does is it uses what are called views, which are virtual tables. Okay, so they're virtual tables over the internal database tables that are used to manage the structure of the schema itself. So there's some common information schema tables that we can use. There's information schema tables, information schema columns, information schema table constraints. And we can use these things to query the metadata in our database without having to look over to the left-hand side as you saw me doing in Azure Data Studio. So let me give you a quick and easy demo of that. Okay, I'm back here at Azure Data Studio, and I'm going to do, let's do a select everything from information schema tables, and I will see all of the tables in the demo database. Your tables are going to look different than mine because you might not have had these other tables put in here yet, but you should at least see books and book editions in here. And this is the same information that you see over here. Okay. You can also look at the columns. And when you look at the columns, you'll see the columns across all tables. So you might want to put a where clause in here to just use a table that you want. For example, where table name is books. And we can look at the columns in the books table. Book ID, book title, and you can see there's my default, and there's my data types. So it's very cool. You can use SQL to query the metadata. And then let's take a look at some constraints. I meant table constraints. That's why I'm not seeing anything. Where table name is books. And this will show me all of my, I got my primary key, my unique constraint key, my 2 check constraints, and my foreign key constraint. So this lets me see all of the different constraints that I have configured on the table. So that's basically information schema, your database. And I realize now that I'm not showing you the right screen, so I apologize for that. So this is what I'm talking about here. This is the script. When I run it, it recreates everything that I want. And that ends up being very useful, like I said, for database development. So now let's go ahead and summarize. So in summary, SQL is domain-specific language. It supports metadata management through data definition language like create, alter, and drop. It supports data management through the CRUD operations, insert, select, update, and delete. And naming conventions are very important so that we know where these objects are, and they need to be somehow globally unique. And then finally, we use information schema inspection to figure out with a select statement what our table names are, what our column names are, and what our constraints are.